Hello, Advanced Math kids. This is the second lesson on matrices that we're going to do. This is 14.5. Just another reminder, these are in the Google Drive folder for the resources. These are not in the textbook or online. The assignments will be submitted on a Google Doc, and I shared that information with you as well on how to do those. I haven't made any specific notes for these for a couple reasons. One, it does get pretty tricky using all these matrices. And also, I think these are fairly review, and I'm trying to keep it pretty basic for you. So if you have any questions, please let me know. I'm not afraid to expand on anything if I need to, but I don't have any set of notes for these. I was just going to go through basically the examples in the textbook and hit a few highlights and look at the questions that I've assigned and make sure I go over any technicalities with those. So 14.5 is operations with matrices. Operations are your addition and subtraction that we're basically going to be doing here, maybe some scalar multiplication. Okay. Remember, the uppercase letters can be represent matrices a lot of times. They use the enclosed brackets. 1, 1 stands for the rows and the columns. So the rows go across and the columns go up and down. Or down. Okay. Example 1, equality of matrices. Two matrices are equal if they have the same order. Order is rows times columns, and each of their elements are the same. Okay, so when it says solve for A11, A12, A21, A22 in the following matrix, they're going to be equal if this is a 2, this is -1, this is -3, and that's 0. So you say 2, -1, -3, and 0. So those are the elements. Okay. So these would be equal, even though those numbers are written differently. These would not be equal. They're not the same. They're not the same size. Okay, not the same order. Okay, matrix addition. Matrix addition, you have to have the same order, and the sum is going to be the same order. Okay, so in order to add, they have to have the same dimensions. In order to add matrices, they have to have the same dimensions. So this is a 2 by 2 matrix, and we're adding it to a 2 by 2 matrix, and it's going to equal a 2 by 2 matrix. Okay, so 2 by 2, 2 by 2, and it's going to equal a 2 by 2. You just add corresponding elements. So we're just going to add corresponding elements. So whatever's in the top left, -1 went with 1. Okay, -1 went with 1, -1 plus 1 is 0. Okay, so 2 plus 3 is 5, 0 plus -1 is -1, 1 plus 2 is 3. Okay, so you're just going to add them across. 0 plus 0 is 0. This is called a 0 matrix. I wonder why. Okay, and these would be add to a 0 matrix. Okay, here on D, the sum of A and B. Well, A is a 3 by 3, B is a 3 by 2. They are not the same order, so it is undefined. Okay, so if you can't add them together, you just say it's undefined. So the same thing goes with subtraction. If you're subtracting, you just subtract the elements. Just be careful if there's a minus sign. So if I go -1, -1, 2, 0, 1, minus 1, 3, -1, 2, okay, that would equal, I'd have -2 minus 1, that equal -3. 2 minus 3. 2 minus 3 is -1. 0 minus a -1. 0 minus a -1, well, that would be a +1. And then 1 minus 2 would be -1. Okay, so if you're subtracting, make sure you distribute that to everything on the inside. If it's helpful, you can change that to a plus and then change all these signs in here if you want to. Okay, sometimes that's a little bit easier. Scalar multiplication. C is a scalar, or called a scalar multiple of A, if C times A is C times every element. Okay, so if I have 2 times a matrix that has a 3 and a 5 in it, a 2 by 1 matrix, that would equal 2 times 3 and 2 times 5, which would be 6 and 10. So that's a fancy way of saying just distribute. If you have a scalar, that's called a scalar multiple right there, and just distribute that. Okay, subtraction sign, we talked about that already. So scalar multiplication, matrix subtraction, you can look through these examples. If they want 3 times A, they're giving you A and B. There we go. A and B. 3 times A would be just 3 times every element. So 3 times 2, 3 times negative 3, 3 times 2, all the way through, and they cancel it off. That would be your answer right there. That's it. The opposite of B would be negative 1 times B. They just take everything times negative 1. So if you do 3A minus B, it'd be 3A, which we have from up here, minus B. So 6 minus 2, 6 minus 0. Go through with the negative, 6 minus a minus 1. That turns to the 7. Okay, so there's scalar multiplication. Scalar multiplication is distribute. If it's subtraction, distribute the negative in there. Here's all your properties. You'll have 1 or 2 questions that kind of cover those properties a little bit. Commutative property does hold. Commutative property of addition does hold. Associative property of addition does hold. This is associative property of scalar multiplication. If you have 2 scalars, you can just multiply the 2 scalars together and then take it times it. This is the identity property. 1 times any matrix would be any matrix. C times the sum of the 2 matrices would be the sum of the scalars to each part, and it doesn't matter if it's in front or back, or that's a double scalar. So this just goes on with some more examples. You can find out, pick however you want to do these. 3 times the sum of 2 matrices. What I would do is I would add the 2 matrices together and then take it times 3. So it would be 3 times 2, negative 2 plus 4 is 2, 0 plus negative 2 is negative 2, 4 plus 3 is 7, 1 plus 7 is 8. So that would be 6, negative 6, 21, and 24. What they did is they distributed the 3 to both parts and added together, they got the same answer. Solving matrix equations. This is, it says solve for x in the matrix, in the equation 3x plus a equals b. Okay, where a equals this, b equals that. So we're going to begin by solving for x. And notice how they handle that 3. They don't divide by 3, they say it's 1/3 times it. So it's 1/3 times b minus a. So then you're going to take b minus a and then use 1/3 as a scalar multiple for that. Okay, so if they had 5x equals a plus b, that means x would equal 1/5 times a plus b. Your scalar multiple you'd use there is 1/5. Matrix multiplication. Find the product of 2 matrices. Okay, let me go see what we're doing with that. Yep. Okay, matrix multiplication, we are going to use a calculator for that. There is a series of steps we can do with it, but we're not going to handle that. So you need your graphing calculator, and you're going to put them in just like we did last time. So I'm going to put in a times b, so I'm going to put in a 3 by 2 matrix and a 2 by 2 matrix. Now when you're doing matrix multiplication, this is a lot harder than scalar multiplication. These 2 values right here have to be the same. And then your answer will have the dimensions of a 3 by 2. So the outside numbers, that is going to be the order of your answer. The order of your answer, that's the rows and columns. These must be the same. If they're not the same, you cannot multiply them. So I'm going to put A in. So go to matrix. I'm going to edit. I want a 3 by 2 matrix. Negative 1, 3, 4, negative 2, 5, 0. Okay, quit. Matrix B, I want a 2 by 2, negative 3, 2, negative 4, 1. Okay, so I'm just going to go back into matrix. I want matrix A times matrix B. And you notice my answer is a 3 by 2 matrix. That would be your solution. So is that what they got? Yep, negative 9, 1, negative 4, 6. Now, if I switch that around, if I do B times A, notice that would be a 2 by 2 matrix multiplied with a 3 by 2 matrix. So these are not equal. So this would be not possible. And you'll get a dimension mismatch if you do that. So if I go matrix, I want to take matrix B times matrix A, you'll say dimension mismatch. Okay? So finding the product of two matrices, use your calculators with that. Here they're talking about that same thing. These are the same. These have to be the same. This is the product, the order of your answer. So 2 by 2 times 2 by 2 should be 2 by 2. 3 by 3 multiplied with 3 by 1, those are the same. The answer should be a 3 by 1. This is a 3 by 2 times a 3 by 4. That would not be equal. That is not possible. Okay, so top of page 914, this is what we're talking about here. These have to be equal, and this is the order of A times B. Okay, properties of matrix multiplication. Associative property works, distributive property works, and scalar multiplication with associative does work. Notice what's not on here is commutative property, and we just saw that A times B does not equal B times A. Commutative property can apply, but it doesn't always apply. Okay, so here, solving a system of linear equations, we have a coefficient matrix. I believe we talked about that last lesson. It's been a week or two since I've done a lesson for you, to be honest. But here are your steps for solving a system of linear equations. And we've kind of pretty much already done this. Write a system, maybe it's algebra 2 I've been doing. Could have been algebra 2. No, we did systems of equations, okay. So we've talked a lot about this already. Writing a coefficient matrix. When you write this, you're going to have a question about writing this as a matrix equation. So my coefficient matrix would be 1, -2, 1, 0, 1, 2, 2, 3, -2. And I'm going to take that times x1, x2, x3. It has to be a column matrix. Because this is 3 by 3, we have to multiply it by a 3 by 1, and that should equal -4, 4, 2. This is 3 by 3, this is a 3 by 1, the answer should be a 3 by 1. So this is a matrix equation from a systems of linear equations, okay? So this is what you see right here. Okay, this is the matrix form. In matrix form, AX times B, it can be written like that. Okay, then you can use the RREF, reduced row echelon form, and you can get your answers in -1, 2, 1. Use that in the calculator. Okay, and I apologize if I'm mixing up classes. I did some matrix stuff in algebra 2. I hope it's your class that we covered that in. Okay, so your assignment 1 through 4. This is some of your vocab. Question 4, I'm not sure if I covered that one. Scalar multiples, I'm looking. Okay, here, top of page 912 is some of the vocab. It's talking about a zero matrix. And A plus 0, so if it's entirely of zeros. In other words, O, that's the zero matrix, a capital O. That's how it's represented, is the additive identity. Where does it talk about rows? Oh, right there. Skip right over it. The identity matrix of an order. That's what what else you need is when you have ones down the main diagonal. That's called the identity matrix. Okay, it consists of ones on its main diagonal and O's everywhere else. So these are your identity matrices. And any matrix times an identity, it has to be a square matrix. Is times itself. So identity is like multiplying by 1. It won't change. Which properties are these? So in question 6, in exercise 5 and 6, match the matrix property with the correct form. Okay, so you have A, B, C, and D. You need to match it with I, 1, 2, 3, and 4. Okay, just match them up there. Find X and Y. These are matrix equations. Don't overthink it. On 8, and you're going to do that for a few steps. Solving, just set the elements equal to each other and solve. 14 and 16, you're doing these 4 steps here. Okay, so 8 through 12 should just be X equals and Y equals. 14 and 16, you'll have several matrices to calculate out. 22 and 24, same thing. You're just adding using scalar multiplications and adding there. 44 and 46, use matrix capabilities of a graphing utility. Use your calculator. Calculate A times B if you can, if it's possible. Okay. Same with 50. Find A times B, B times A, and A squared. A squared is A times A. And then 64, solve this system using matrices. Okay, so show me what matrix you used. So write the matrix equation. I want to see the matrix equation. And then solve it. Okay, and I think that's it. So hopefully these matrices go a lot smoother for us, and we got through all those conic sections and everything. I think the last lesson might be a little bit tricky, but the matrices should be a nice break for us. So let me know what questions you have. We'll talk to you later.